So, welcome everyone. Over the next 30 minutes, we will talk about modern deployments at scale, cloud deployments at scale. So, let's go. Okay, thank you. Is it better? Okay. So, from this talk, basically, what you will learn is what benefit continuous deployment as an approach can bring to your company, especially in terms of market growth, customer satisfaction, and things like that. And how difficult or what are the challenges as an organization you will face while adopting it. So, let's first start with a brief introduction about SECUTIX. So I am from SECUTIX. SECUTIX is part of the ELCA group, founded in 2007. Basically, we are a ticketing SaaS provider. So basically, customers or event organizers use our platform, which is SaaS platform, to sell their tickets for their event. Our customers, of course, include a lot of customers in Europe, but for example, Opéra de Paris in Paris, Palio in the Switzerland, I hope everyone knows about it, is one of our customers. And as you can see, we really operate at scale, meaning, for example, we process almost 45 million tickets sales per year. We are deployed worldwide. So in that little map, you can see like we are in UK, we are operating in Europe, America, South America, everywhere. Except Asia, we still need to crack, but okay, maybe one day. And we are hyper scalable. So just for this year, I think this article is 25, and the Palio ticket sales were like 200,000 tickets in 13 minutes. And those were really live tickets. We are really selling those tickets. So that roughly translates to 15,000 tickets per minute, if I'm not wrong. And just to add on top of it, it's not the most demanding customer on our platform. So we have much more high demanding customers. And that's the idea is that we really care about performance and scalability of our solution. So now we go back a bit in year 2021. So this is how SECUTIX engineering was looking at. So we were a modular monolith. So to explain a bit, it is like everything is a modular. We have a modular approach. We have sales module. We have payment module. We have ticket shop module. But they are all deployed together. So it's still a monolith in a sense, but the things are still separated out. Since it was founded in 2007, and we are talking about 2021 here, so we have grown and we have 5 million lines of code. We are doing once a month delivery in 21. So this means once a month, we were integrating everything, testing everything very courageously, and making sure and praying that we have no regressions. And that's how we were in 2021. And then we had a big, sufficiently big engineering team. We have like 10 teams from development, QA to operations. And we have almost 80 FTE, full-time equivalent of team size. So that's the size we are talking about, right? And let's check what are the challenges we were facing. So obviously, as I said, monolith in 2021 was not going to scale a lot. So we were already hitting those kind of performance bottlenecks, and I think everyone will agree. We were not scaling to the demands of the customer. On the other side, we had delivery delays because we could not test on time. We had challenges. So there were 10 to 20% of deliveries which were delayed, and that was not good. Especially on Swiss standard, we want to be on time. And then the other challenge which we were facing is that we had a higher regression ratio. So regression is like something which was working, and then we make a new release, and it stopped working. So it's bad for the customer, right? And that's what we call regression. And we had like 25% of the issues which were reported were really regressions, like something was working and it stopped working. And the worst part is like to fix those urgent issues, we took 2 days. And this is why, I mean, I'm talking about from analysis to the fix is deployed in production. It took us 2 days because of this whole monolithic thing. And we had a low customer satisfaction. I think it's not a surprise because everything is quite big and falling apart. So 2022, we decided to do something about it. Okay, so we had 2 mandates from the engineering head of engineering. Objective number 1 was to basically split the monolith. So, but we did not go to the typical microservices style because we are huge, basically, and we cannot just go to really at small microservice level. So we call it, we try to split the whole system into functional domains. So it's like a bigger size of microservices. We call them as cells. But this is what we do. We try to decompose everything into smaller cells. And the idea was that each cell should be able to deliver autonomously in production. That's the objective number 1. Objective number 2 is we should increase the time to market. This means that we cannot wait for 2 days for an urgent fix to arrive. We cannot wait for 1 month to ship a feature. So these were the 2 challenges. So basically our solution was, okay, let's adopt continuous deployments. So continuous deployment is basically, the point is like you, instead of delivering huge stuff once a month, you split them into smaller chunks and you deliver frequently. That's the whole part of the continuous deployment. So, and you are deploying in production. It's not like something in integration which remains and it never goes in production. You deploy in production. So the key idea is smaller, frequent deliveries. And to have that, you need fully automated deployments. So that's a good idea, right? And I think everyone agrees, like, okay, looks good. But what it means, actually, and it means that if you want to have these, you need these kind of things. So first is team ownership. You want to push things in production frequently, but this means that you need to have a team which is continuously looking at the things in production monitoring, and things like that. Then because you are you want to deploy many times a day compared to once a month, you need a standardized deployment pipelines. And that pipelines are not just from build to, let's say, integration, but it's end-to-end, right? Build to production. Then we were using release-based branching model for making production release. And this will not scale because to manage the release, branch, and everything, it took us like, even we do all the automation, took half a day to manage release. So it's not going to scale. It's not going to meet our requirements. So we adopted this trunk-based development approach, which is basically saying that, okay, there are no release branches anymore. Your master or the main branch is the only release branch, right? So whenever you change or make a commit or merge to master, that becomes a potential delivery. So that's an idea which is new, which is but for continuous deployments, it's really the key. And then again, so this is all about pushing. But okay, what about production, right? Production matters for all of us. And that means that there should be some deployment safety, right? And it means that there should be some guardrails to make sure that the things are properly done and things like that. And because we are a big organization, we need some kind of a governance overall. So we give a lot of control to the teams, right? Autonomy and all those things. But as a company, we want a governance on quality, performance, and security. So the platform, we call them, the name is Quantum Platform, and it is not related to anything about quantum engineering. So it's just a name. But here in this picture, what you should focus is it's a delivery pipeline, as I said. And on the left-hand side, which you see is a build stage. And on the right, extreme right, you see a production. And that's the key idea, right? It is end-to-end. When a developer clicks on this Build Now button, a master builds. And yeah, obviously we build the code, we do the linting and all the things, the quality checks. The next stage is the infrastructure stage. So this means that in the code, in your code itself, you can write Terraform code to provision your custom infrastructure. And the pipeline is capable to actually plan that infrastructure change, have your review, and then actually automatically apply that. And that's the key changer for us. Then after the infrastructure, you have these staging environments, let's say. We test in isolation, then we go to the integration test, then we go performance test, then if some manual tests are required, we go to manual. And then you see there's a small button which we call production release, approve or reject. And that's the only manual action, let's say, where whether the release manager of your cell or of your domain can say, I want to push this release to production now. And when he clicks on that approve button, the same change is rolled out on production. So it makes a change on the production infrastructure, then it goes to pre-production, and then you go to production. So the key idea is that it's like a change. Any change can seamlessly flow to production if it meets all the quality gates from build to manual test. And there is no manual, no creating branch, no nothing, right? So as you can understand, we focus on standardization. It's build to production, from build to production, and it is fully autonomous. This means that this pipeline doesn't depend on other pipelines. If, for example, this is a sales pipeline, for example, it doesn't depend on front-end pipeline. There's no coupling. And that's the key idea. So here I present a bit of quantum blueprint. So it's a bit complicated, but it's simplified, let's say. So we are using Amazon, AWS, as our cloud provider. And the platform is actually built what we call factory pipeline. It's a thin layer on the Amazon CI/CD services. So we use code pipeline extensively. We use code build, code deploy, and ECS Fargate extensively. The key idea is it's a very thin layer. So we don't want to reinvent the wheel of CI/CD. This we leverage from Amazon. What we want is a standardization, and that standardization is on the top, right, factory dashboard, where you see those concepts coming in, build to production, quality gates, and all those ideas. So these ideas which we want for governance on our platform, we build on top of the layer of Amazon. And that's the idea. So it's a thin layer, but it's a high value. It provides standardization, and it provides ready-to-use pipelines. So as a developer, they request a pipeline, we do it in half a day, and you are ready to go. So when I made this blueprint with my team, I was on cloud 9, and we are tech engineers, right? And we thought, like, we cracked the problem, and I will present to my CEO and all the high management, and they will say, okay, Ashish, you did a great job, let's try to do it. And the response was quite surprising, actually, because every team was kind of shocked. And you see, like, developers were saying, okay, what does it mean? Am I really going to be responsible for my production? Remember, they were never touching the production directly. They were always once a month, which managed by operations team. It's a change for them, right? And then it's the same for quality assurance guys. They say, oh, Ray, you want to test, you want to rely on a developer and push a change automatically without any manual testing? Same for factory guys, right? They said, okay, what are we going to do if everything is automated? What are we going to do? Operations the same, like production, safety. And the customer first was really scared. They said, okay, you are going to use production as development environment, and we are not going to allow that. So as a company, basically, we saw a big, let's say, hurdle in adoption. So the idea was interesting, but we needed to solve the challenges which every team was facing and make them comfortable. So the challenge number one was, what about feature development for the developer point of view? So the key idea here is, and it took time to explain and build the practice, was to separate feature delivery and rollout. So when delivery is like you have your feature, but you split them into smaller chunks, right? You can push them to production transparently, seamlessly, with the help of feature flags, right? And because the feature flags are disabled, they are never visible to the customer. And the idea is like you are getting continuous monitoring or feedback from the production. But your feature is not rolled out. It's just like you have a data model change. You can do it without informing customer, right? It's transparent to the customer. And the rollout is another step. Rollout begins from production. You start in pre-production activating your feature. You validate in pre-production. If you have bugs, you go back. You fix the bug in the delivery pipeline. But again, you come back to the rollout. You start deploying your feature for a small set of customers. And then you finally roll out. And this was the change in SECUTIX mindset, because the idea was like, okay, when we implement the feature, it is instantly available for all the customers of SECUTIX worldwide. So the idea here is like from this point, we get quick feedback from production. We get reliable deliveries because we are testing things not in the whole chunk, but in smaller chunks, right? And this means that if something fails, we get to know earlier. As I said, the delivery and rollout are separate things, and the rollout can take days. And this requires a mindset shift, right? So the next challenge is actually very interesting, and think about it, right? As I said, it's a modular monolith, so you can imagine it's a very highly coupled system, right? The back end, front end, because they have been never deployed separately, you can imagine it will be very highly coupled systems. And the challenge is, how can you provide pipelines which can deliver autonomously? That means a back end can deliver without a front end. That sounds strange, actually. I mean, in 2021, it was very strange for us. And so here in this picture, actually, you see the green thing is the back end, and it has its green pipeline, and the front end is an orange thing. It has its yellow pipeline. So the key idea is like obviously the front end depends on the back end, obviously. But the key idea is like when front end is testing itself, its integration with back end, it is not testing with the, like in the beta, for example, the front end is not testing with the beta version of the back end. It is always testing with the production version of dependencies. And that's the idea, right? When you want to separate the things, you always have, we call that independent company mindset. You think the back end and front end are two different companies. You cannot have access to their internal staging environments of other company, like you have in any other company, right? So, and that's the key idea. So when you implement this idea, you gain autonomy. But it's a challenge, because this means that you need to enforce the contracts between the back end and the front end. This means that the back end must be always backward compatible. It cannot change an API. It cannot delete or remove a database column without adapting the front end, right? So there's a strong contract on which must be respected. And then the other side, which is not obvious but is important to realize, is obviously the front end here is not really going to the production back end, but we have what we call a production-like environments. This means that environments installed with production version, but not really production. And this means that for this kind of testing, you need these kind of dedicated environments, right, to decouple the pipelines. This is how it is. This is the magic, actually. The third one is actually, so okay, we say, okay, we do autonomous, we do separation, we gain autonomy and everything. And now the question is like, okay, is it enough? Can we just rely on our test, which we have already? Is it sufficient? So the idea is like, okay, we have quality gates. So as you saw in that picture, like there was a lot of quality gates. The key idea is those quality gates are incremental in nature. That means that For example, we have a quality gate which says that the code coverage must never decrease. So that means that if you add a line of code, it's okay to add, but your coverage is not decreasing. This is what we call incremental quality gates. So it is very similar to what a clean as you code approach is, right? But that is more on the Sonar side, but this is also the same on the platform side. Then we treat not only functional tests, but we also take performance and security tests into account. And that's also the key idea. When we're talking about these functional domains or cells, it is not only the functional aspect, it's also the non-functional aspects like performance, how quickly the system is reacting to the surge of request, and what about the application security itself. And then the other main idea is like, whatever be the change, it could be small, big, infrastructure or application, it has to go through this test of pipeline. If there is something which is not complying with quality gates, it doesn't go through, no matter what. But it's still there is something missing. We can do better. And the other better approach is, okay, let's try to also have some security in way we deploy the things, right? So because testing is good, right? We should test as much as we can, but there's always a bug which you will have in production, which you will not be able to test in your test environment. And that means that you need to be more careful when deploying things in production. So the idea is like you're pushing things fast, but then you're deploying in production very slowly. That's the key idea. So, and we use this blue-green deployment. So basically the idea is like when we deploy a new release on a new version on any environment, we slowly shift the traffic to the new version. So we have a blue and a green version, and we slowly, like here, for example, we are shifting 10% traffic every 6 minutes. So that means over 1 hour. And during this traffic shifting, we are aggressively monitoring our alerts. And then, if those alerts are firing, no matter what the analysis is done afterwards, this we don't care. If the alerts are fired, we automatically roll back the deployment. And this is all thing is automated. So it's what we call conservative mindset or production safety mindset. So we do the analysis later, but we first roll back the deployment because that is the thing which is going on and creating most probably 90% of the things, right? And then we have canaries running every 15 or 10 minutes, which are checking that the critical production things are running fine. So the idea is, again, can we do better? Can we go one step further? And in the beginning of the presentation, I told you like we have worldwide customers, right? We have many customers, 100, 200 customers. Can we take advantage of this? And yes, we can. So this is what we call production wave, right? So instead of hosting all the customers worldwide in one environment, we shard them in several environments, and we do them purposely, right? We do them deliberately, even if they don't ask, because the idea is that when a change is released, we sequentially deploy this change one after the other on each environment. So if we first test the change on a smaller set of customers. We bake them for 1 hour, as I said. If that goes through, we go to the environment 2, which has more critical customers. We bake them there. And then we finally go to the most critical customer, which might not be happy if you have a regression. So, this is giving confidence to our releases. This is giving reliability to our releases. So, as I said, basically, every change must pass through the quality gate. There is no major minor in quantum world. Testing is necessary, but not sufficient. This is our learning over 15 years of experience with ticketing solution and safety mindset. And with all these things, it means that the rollout can take time. You cannot have something like you will deploy in 1 day for customers. It can take probably 4 days, or it might even not go in production because alarm was failing. And that is perfectly fine. That is perfectly fine. So with all the things which I said, now where we are. So So objective number one was partially met because we could not obviously split the whole monolith and have all the things on this domain. Yeah, so this is a work in progress. But the systems which we were able to split and put, they are showing promising results, right? For example, the time to market, we can see those systems are behaving better. And for example, the deployment frequency of the systems which are now on Quantum are deploying like 12 per month. So remember, once a month to 12 per month. And this 12 per month is just because they don't want to deploy uselessly. But the pipeline here is, for example, capable to deliver like 1 per 2 hours or 3 hours, right? We could clearly see an improvement in the time we can fix the urgent bug fixes. So remember, this was taking us 2 days. Now it takes us 4 hours. That's bringing customer back. That's bringing the satisfaction higher. And the lead time means basically the commit. From the time the commit is made to the time it goes in production is like 2.5 hours, right? So this means that you can really have quick pipelines. What we were expecting was like maybe we will see also with all these revolutionary things, we will probably see a gain in efficiency. That means that with the same capacity, with the same amount of resources, we will be able to do more, right? We will be able to do more development. And this is what we could not see. I mean, this we could not see. It has not decreased, but it has not increased also. So the key takeaways. So the benefits are quite clear. We have time to market. We improve the reliability. We improve the customer satisfaction. The tools and techniques which we use are many, actually, but I try to highlight here. So basically what you need is scalable autonomous pipelines. I would recommend to use trunk-based if you are really aiming for delivering every 2 hours or 3 hours. Leverage blue-green deployments. Use feature flags extensively. Otherwise, I think it will never work. You need to have a very accurate real-time monitoring of your system. So here we use a lot of Amazon services which are giving us real-time reliable metrics. And then leverage canary testing, right? So you make sure that you have your tests, you release very slowly and have those canary tests running through them when validating those releases. And the last one is adoption. And don't forget adoption, because remember, continuous deployment is not a technological change. It needs to be adopted by the entire organization. It's not really for developers only, it is for everyone. And to leverage or to accelerate adoption, you need a common platform, you need extreme team ownership, and you need a mindset shift from all verticals, starting from developers to customers. That's the end of my presentation. I hope it was you could bear with my English, and it was a little bit interesting, so that for you. Okay, and I'm happy to take some questions. Thank you.
Any question?
Là. Là-bas.
Good evening. Thank you, Ashish, for the presentation. Just one question about the software itself and the structure of software. Did you standardize all the features for all your customers, or it's for each customer a specific features?
No, we are a product, so we have a standard feature for all the customers.
Yes. Worldwide?
Yeah.
Okay.
There is no if else.
Okay, because okay, and how do you manage all the process? How did you let's say, what inspiration did you have in terms of process, in terms of project? I mean, you see to keep on track all these features, all this improvement, all this code, and so on. Did you have some inspiration to apply this process, or you did yourself?
Okay, so the inspiration for this one. So actually, yeah, the inspiration was Amazon. I forgot to put the link, but basically there's an Amazon Builder library where they kind of recommend what they do at Amazon. And this is not a new concept. The continuous deployment is a concept which big companies are already using. So and I think the concept is easy, is attractive, but what was really challenging to implement, to really decouple the pipelines. I think we spent like 2-3 months to decouple the system, because as I said, we were having a monolithic system, you know, with tight coupling. We need to extract the APIs. We need to make sure that the backend team knows their API. They need to make sure that they have tests which are validating those API contracts. These kind of things were not existing, right? So that's the idea. So the inspiration was from the Amazon Builder library, the articles, the blogs, and then we built this platform. That's it. I hope I answered your question. Anyway, yeah?
So thank you for the talk,
Yeah.
first. Do you use some messaging queue like Apache Kafka for the pipeline between your different components that make your solution handle the incoming ticketing, etc., at that speed, that pace?
So you're talking about the pipeline itself, or?
No, the application, because
Yeah.
the ticketing system, like you presented in the one
Yeah.
of the first slide,
Yeah.
it's a huge, you can have a lot of query per second or per minute.
Yeah, yeah.
And usually when you can saturate any
Yes.
system, and usually one way to solve this
Yeah.
is to implement a messaging queue.
Yes, yeah.
And one of them that
could be Kafka.
is Apache Kafka.
Yeah,
For example,
yeah.
the CFF, the Railroad implemented
Yeah.
this kind of stuff.
Yeah, so the honest answer is right now no. But the reason is actually because everything was a monolith, was very hard to implement anything, you know, because if we add this messaging layer to make sure everything to adapt, it was a challenge. It was like a 6 months project. So what we did now is we split into like a sales or a backend has its own cell, right? And now a backend can implement this asynchronous, if I understood well,
Yes,
basically
exactly
asynchronous architecture using their cloud native or Kafka technology. So for me, this platform is right now what we are doing is we unlocking the doors of modernization inside our company, and then we let the teams to choose the right architecture and modernize their systems. So yeah, so that's it. So right now the answer is no. I understood you, but for me it's in progress. What you said.
Probably just a quick question. Yeah. It was a challenge to handle the cost of Amazon, because I heard some company in the beginning is fine, but when it scale, you need a FinOps or something.
Yeah.
So do you have a feedback?
Yeah. So. Obviously, that's why, from my personal experience, a lift and shift strategy in the long term doesn't work. It gives you a quick win, and you quickly go to Amazon. But if you just stay like that, you are going to burn yourself. And the adoption here is like what we are doing is like for sales, what we are doing is like, okay, you have a budget of $50,000 per. I'm giving you a rough figure per year. And we say that this means that every sale, like a number of tickets which we are selling, you should the unit cost should be like $1. And the point is, we often break this barrier. So the sales is breaking, but then the optimization, cost optimization strategy kicks in. So this means that at the company level, we know this is not okay, and we need to solve it in 6 months.
So you monitor it?
Yeah. Yes. I'm not sure I can. Yeah. Okay. I can show you quickly.
Because I hope that it's not more expensive than the cost of the ticket.
No. No. It's not that bad, to be honest. But I can show you quickly if I have it. No. Sorry, I'm offline. Sorry, but the idea is like the whole this Amazon structure, as you said, we need a FinOps, but our strategy is also we try to decentralize a bit to the teams. So having their budgets and having this unit cost KPI for them, and we track them at monthly level.
Okay.
So we treat that as a cost SLO, if you can think like that.
Okay. Thank you very much.
So but we are, I mean, we are not very far. Huh? So maybe next year I can give you better feedback on this one. Yeah, thank you.
Try to be quick. First, a remark. In one of the last slides, you put time to market increase. You probably wanted to say time to market decrease.
Okay.
Just to check.
Yeah.
Things about aggressive monitoring, I believe you use a lot of in Amazon CloudWatch. But then there's a cost of metrics.
Yeah.
One metric name basically costs you 30 cents. So that means 1,000 metric costs you, what, $300?
Totally right.
I mean, this is very easy actually to get actually into this costing.
Yeah.
But I think you partially answered that. And last question is,
yeah, please go.
one of the first slides where you showed you the stages of deployment. So did you wrote this custom UI for this, just as an internal tool to do this, or this is just a slide?
Yeah. So I guess you are talking about, wait, let me just, no, this one.
Next one probably.
Okay. It's this one,
This one,
right?
yeah.
Yeah, we wrote, we are a small, I think this one is not complicated. So for me, yeah, we wrote, to answer your question, yes, we wrote this one.
One last remark. I think, well, you sell tickets. Tickets, essentially, you've got one product. So for you, prod versus pre-prod data is not such an issue because you simulate the pre-prod by injecting lots of synthetic data to kind of to simulate some kind of a peak loads in the production which you have. And this is probably how in pre-prod you can really test your loads and so on.
So yeah, so the load testing is very interesting, and I think, so before this thing, what was happening is we were having system level load tests, so everyone was pushing whatever change they want, and once a month before a delivery, we were running this load test. There's a performance team which was running it and saying, okay, you broke that, you broke that, you broke that, this is not okay, right? And we wanted to find a solution for that. So what we are now doing in this one, for example, there's something called load test here. So it's not a system load test. It is that cell load test. So this is like if SECUTIX wants to sell 100 tickets per second, as an architect, we have broken this down. This means that the backend, this API should operate at 50K, whatever, right? This is the load criteria a backend API should satisfy. And then we try to run that test here. Of course, we try to simulate the data, but we leverage a bit of customer data and anonymize it, and we use it there. But we find issues because our experience was most of the time it was the issues were because the guys did not know that they have to respect their performance SLA, So we were just talking about high level SECUTIX level SLAs, and we were never breaking it down to cell-based SLAs. And here, I'm not saying everything is perfect now, but we have less problems to deal with.
You've said a cell is not a microservice, so what is a cell?
Excuse me. Sorry to stop you.
Sorry.
Yeah, because we have to begin the next talk. Can you keep all your questions for the networking part?
Okay. Thank you very much.
Merci beaucoup encore.